All right, we have a request for drawing all chiral secondary amides. So before I even finish reading the question, I'm going to draw what the minimum chiral, well, minimum secondary amide, and we'll work on chiral later. You're going to need a carbonyl. You're going to need an N. It has to have a bond to C. Okay? And you're not allowed to skip H's on nitrogen. There you go. So there's the minimum right there. So I'm going to write that down. That's the min. So, you know, this is something you can do to pass the time as you think about how you're going to finish this question off. And it's fun to watch the teacher do stuff like this. Because now I'm going to have 8. Oh, that's not fair at all. And I'll do one more. So since every molecule has to have at least that, let's start with at least that. All right, now my strategy, personal strategy. I've got 6 more carbons to go because I've only written 2 carbons on the page. And I realize this is going to be more than 30 molecules. It's crazy. Yeah. I don't even think I finished my own answer key. If you look at the answer key, and many, many, many more. So this could have been a whatever that lady's name is I mentioned by mistake before the video. It could have been another one of hers getting 100 points more than everybody else on the test. Okay. So I'm just going to put 6 more carbons on one side. Now, if you put them in a row, you don't have any stereocenters. I'm just saying that. So I'm gonna put 5 in a row, and then see if where I can put a 6th one to make a stereocenter. So here's 5 in a row. 1, 2. I don't like red too much. Anything except blue. 1, 2, 3, 4, 5. And if you put the methyl group here, it's not a stereocenter. I hope you see that. But it could be here, here, or here. And they're all stereocenters. So it's chiral. And each one, R and S, gets a point. 1 point each. So how many molecules is that? 2, 4, 6. No, they don't start there. They start there. 2, 4, 6. And you can have one here. And that one is S. Do a single switch so you don't have to do too much thinking. That one is R. Move the methyl one more over. That one is R. Do a single switch. That one is S. Move it one more over. That one is S. And single switch. That one is R. Okay. And then how about doing 4 on the left? And 2 more methyls. I'm not going to do too many more here because I think you're going to see when the possibilities, I hope you've already seen the possibilities are getting out of hand. 1, 2, 3, 4 in a row with, well, if I put a methyl there, that's no good, but there is the stereocenter, right? Then I can do that there and do a single switch. So this one is S. Do the single switch. That one's R. Now move that second methyl to the alpha position. 1, 2, 3, 4. 1, 2, 3, 4. And methyl there, and alpha position instead of beta. And that one is S. And we got down, up, down, up. Single switch will be R. And I'm just going to vocalize. You could have put this, start with your thing here and put this all the new carbons here in a row, and then do the same strategy to get 6 molecules, and so on and so on and so on. People, just the answer key reveals like there's at least 30. I've actually done the question that's the equivalent on your test. There are not anywhere near this many. It's a much smaller molecule. Okay, so it won't be a many, et cetera, et cetera. But I think we have to leave it somewhere.